Okay, guys, welcome to another lesson. And in today's lesson, we are going to be looking at, as you can see on my screen, Venn diagrams. But before we start looking at our Venn diagrams, there's some of you guys who have your mics unmuted. We only unmute when we are asking questions. So please, unless you're asking, I can see it's Gamogelo. Just keep yourself muted, okay? And you'll unmute when you feel a sense of confusion or you have a question. But today we're going to be looking at Venn diagrams, but before we kickstart for Venn diagram, we just want to have a question that is related to the previous session, which was where we're looking at three diagrams: independent events, dependent events, the product rule, the complementary rule, the addition rule, and so on. So what we are going to do today is to start off by looking at a question that continues from there before we get into Venn diagrams. And the question we are going to be looking at is the question on the screen, of which the question reads, the events A, B, and C are such that A and B are independent events, B and C are independent events, A and C are mutually exclusive events, and their probabilities respectively are probability of A is 0.3, probability of B is 0.4, and probability of C is 0.2. And we are asked to calculate the following: the probability of both A and B occurring. So this should be very easy, guys. If you look carefully, the first question is pretty much straightforward. 10.1, we need to calculate the probability that A and B will occur. But we were told that A and B are independent events. So let's go ahead, 10.1.1. So they told us that A and B are independent. And if I may remind you, whenever we have independent events, when we are looking for the probability of A and B, which mathematically I taught you that we write as A and B, the probabilities if these events are independent is the same as their product. So it is the same as having the probability of A multiplied by the probability of B. So it means the answer they're looking for the probability that A and B will occur, is simply the probability of A, which is 0.3, multiplied by the probability of B, which is 0.4. So that is probability of A, and this one here is probability of B. So what is the answer that we get, guys? I will need you to have your calculators very close to you, but I'll also pull up mine in the interest of time. So please punch in these numbers too. So let's go ahead. So we have 0.3 multiplied by 0.4. You look carefully, we end up getting as a decimal place 0.12. That is what we end up getting as the probability of A and B. So probability of A and B is just 0.12. Do you guys understand? If you do, give me a thumbs up. If you don't, please ask. Right. So just a reminder that this formula, it works for independent events, as I previously had said. So let me just quickly make some space here. I really advise, if you are not sure of this, to check out the previous session. So we covered this in length. So the formula that I have here works for independent events. So, sorry, probability of that. Independent events. So if events are independent, we are allowed to use this formula. Right. So let's go to the next one, which is 10.3. Sorry, it is 10.1.2. So they want us to calculate the probability that B and C occur. But look at what they said also. They told us that B and C are independent. So they say now we should calculate the probability that, what did I do? No, guys. Can anyone correct something here?
10.1.1, they said they want probability of both A and C, not A and B.
Okay, so we did A and B. So let's leave A and B like that, and then go and deal with B and C. So that will just leave it afloat, and let's do 10.1.1. So here they are looking for A and C, not A and B. So if you look carefully, they said A and C are mutually exclusive. Guys, I'm so happy. So if you look carefully, they tell us that A and C are mutually exclusive. This reminds me of something which I taught you on the previous lesson. So A and C are mutually, this was very easy, exclusive. And if I may remind you guys, mutually exclusive events are events that cannot happen at the same time. Okay, so you can't have them happening at the same time. So let me maybe quickly put up that. So mutually exclusive events, these are events that cannot occur at the same time. So we are told that A and C are mutually exclusive events. And for mutually exclusive events, the probability of those events happening are 0. So probability of A and C, that equals 0. And this is because these are mutually exclusive events. You guys understand? This is awesome, isn't it? If you do understand, give me a thumbs up. If you don't, please ask. What part of this doesn't make sense? So please make sure that you guys do revise the lessons, okay? We did cover mutually exclusive events on the previous lesson. So this was as easy as giving them a 0. Then let's go to the next one, 10.1.2. And on 10.1.2, what they looking for there is the probability of B and C occurring. Look at what happens. B and C are independent. So we are looking for B and C. And we are told that these events are independent. And guess what? We know a thing or two about independent events. The probability of independent events B and C is always given by the product of the probabilities of the two events. So this will be probability of B multiplied by probability of C. So this means our answer will be probability of B is 0.4 multiplied by probability of C is 0.2. So this will end up being 0.8. Correct? No, I think 0.8. Let me confirm. So you have 0.2 times 0.4. That becomes 0.08. Do you guys understand what we did here? Let me see. Yep, that is that. Let me confirm the previous one with the 0.2. So why is my calculator not moving here? 0.3 by 0.4. So that becomes 1, 2, shift 1. Yep, that is okay. Do you guys understand what happened here? So that is our probability of B and C. Done with that. Now, let's go and calculate 10.1.3, which is, we should calculate the probability of at least one of A or B occurring. So for this question 10.3, they are asking us, what is the probability of A or B? And if you remember, guys, mathematically, I taught you that the or has the sign U for union. So essentially, they are asking us, what is the probability of A union B? That is the question that they are asking us. And if you remember, guys, I taught you something, which was that the probability of A or B, this is always given by the probability of A plus the probability of B minus the probability of A and B. This, guys, we covered when I was introducing you to probability. This was under the addition rule. So it is very important that you go and revise your lessons. This was under your addition rule. So we can now go ahead and calculate this because we do have the probability of A and B because they are independent, which we have calculated this side. So we can go ahead and put that up. So the probability of A and B, we calculated, guys. Probability of A and B was just the probability of A multiplied by the probability of B, which was 0.3 multiplied by 0.4, which gave us 0.12. Let me make some space. Sorry, independent. So that gave us an answer of 0.12 as the probability of A and B. So we can now go and finalize the probability of A or B by simply adding the probability of A and B and then minusing the probability of A or B. So if you look carefully, probability of A 0.3, probability of B 0.4 minus the probability of A or B, which is 0.12. What is the answer, guys? Anyone?
0.58.
0.58. So that would be your answer for that question. That is the probability that A or B occurs. Do you guys understand? Where's my thumbs ups? Right. Very important that you do get these problems correct. Okay. So done with this question. This is what you were expected to do, guys. I hope you understand and please practice. Right. So let's now jump into Venn diagrams. What is the story there? So as many of you remember from grade, I think 11, So whenever you're dealing with a Venn diagram, we'll be usually dealing with this here. So it will be a box. So we'll deal with three types of boxes actually. We'll have a circle. There'll be one like this, another circle here, my odd looking ones. And then there will be a box that will have two circles. So you'll have one like that, intersecting with the other ones. That will also be part of your Venn diagram work. And the third one, which you all can anticipate, is the one that has three circles. Inside of it, usually they are combined. So you'll usually have a circle like this. Then you have a circle like that. And then you have a circle like that. So my circles are very odd looking, and that is okay. So these will be your three Venn diagrams that we'll be dealing with. So we could even make the circles to be three and not combine them, but this is what we will deal with. So this will be event A, this will be event B, A, B, we'll have A, B, and C. So this is just how your Venn diagrams look. What usually happens with Venn diagrams is that at the corner here, what we usually do is we put in the number that is not part of what is happening inside here. So let's say, for example, as I will give you, like, let me give you an example to explain what I mean about Venn diagrams. So let's consider a situation where you're at school and there's people who play netball and others soccer. So consider what we want to do is we want to consider the case below. What is the case? So the case is that we have a school, and that school has soccer and netball as a sport that the learners can play. Okay, very easy example. So let's have a look at what is happening here. So we'll have learners who are going to play soccer. We are going to have learners who are going to play netball. So we are going to have netball here, and then we are going to have soccer. So let's put up our circles. So that there. Let's make it slightly bigger and copy it and put it up like that. So there you go, guys. We have netball and soccer like this. And obviously at school, as you know, there's nerds who don't play either of these. So let's consider a class. So the grade 12 class, which you are currently in. So the grade 12 class has in total 34 learners. And we'll build up on this. Let me move my Venn diagram here. And out of these learners, we have 18 learners play soccer. And we have 4 learners who play or who do not play in neither sport, who do not play soccer or netball. And then we have learners who play both. So we have 8 learners. They play both soccer and netball. So what we are required to do here is to populate this Venn diagram accordingly so that it reflects what we have here. So this Venn diagram must express exactly what we are told above here. So the first thing that we always do, guys, is on the corner, we always put people who do not play, who are not participating, essentially. Here, what we do is we put those who do not participate, who do not play. In the case of other problems, it would be whatever which is excluded. So in this case, those who do not play, they always sit at the bottom of our Venn diagram. So if you read carefully from our problem, it's only 4 of them. So 4 of them don't play here. Okay. And then the next thing that we can easily put is that there's people who play both soccer and netball. So those people are very easy to put in because they're here in the middle, guys, isn't it? So they play both. So they must appear on the side of netball, but they must also appear on the side of soccer. But we are also told that the total number of people who play soccer, so if you think carefully, soccer as a whole has 18 people. So if 8 of them are playing both soccer and netball, how many people play soccer only, guys? Anyone? So the total number of people who should play soccer are 18. But there's others who play soccer and netball. So on the soccer side, how many people should I put now so that we complete the puzzle? So on the goal side, if you observe carefully, we should put in 10 people because the 10 will now make a collective 18 of soccer. So now what we are missing is the X. How many people are playing netball? But we should remember that we have a total of 34 learners in the class. So we have X plus, there is that 4, okay? And then there is the 8, which are playing both. And then there is the 10 that is playing soccer only. And this should give us 34 learners. So it means our X, which would be the people who are playing netball only, would be 34 minus 4 minus 8 minus 10. What is the answer, guys? So the 34 here is the total number of learners. What is the X, guys? Where X will be the number of people who play netball only.
X is 12.
X is 12. So X is 12. And this would be the number of people who play netball only. Okay, that is what the 12 would be. Now let's dive into, now that you understand this, I'll take my Venn diagram, put in the 12, okay? And then we can start dealing with questions. So let's now put in the 12. So we only have 12 learners who are playing netball only. 4 are not playing. And remember, our total number of learners is 34. Now that we have this, we need to think of this problem here. I'll call this A. So for A, we are required to to determine the probability that if I get in class, how likely is it that I'm going to be able to pick someone who is playing soccer? So let's say we get in class. What is the probability that we will pick someone who is playing soccer only? So what is the probability that someone randomly picked in that class plays soccer only? So essentially the question mathematically is, what is the probability of S? And what is very important is, guys, this term here, soccer only. So what is this probability going to be? Anyone wants to give it a shot?
10/34.
Yep. So if you observe carefully, you should realize that there's 10 people, or there's 10 learners who play soccer only. So that is what you were supposed to first note. So there's 10 learners who play soccer only. So since there are 10, you should put 10. The total number of learners is 34. Okay, so that is our probability. And what is this as a decimal, guys? Or maybe let's leave it as a fraction. It's okay. No need to change it to a decimal. Then let's go to B. And for B, we have a similar question. What is the probability that we, in this class, pick out someone who plays soccer? So what is the probability that someone randomly, or that someone is randomly picked, plays soccer? Yeah. What do you think about this, guys? Any thoughts on this one? What is the probability that someone randomly picked plays soccer? Anyone, guys? So how many people in total in this class play soccer?
It's 18.
Yep. So we should say our probability that we will get someone who's playing soccer, it matters not whether they are playing it soccer only or not, but there's 18 of them out of the 34. So this would be the correct answer. Does it make sense, guys? There's 18 people who play soccer in total. The difference with the previous problem was they said who plays soccer only. But if they remove the only, there's people who play soccer and netball. So when we are trying to pick players who are going to play soccer, we'll pick them because they can also play soccer. That is why it is 18. Right. So with this, guys, let's go to the next question, where what we are going to do is, because we have our Venn diagram here, Let's go. We are gonna go. Let me quickly add my pages here. So there's our Venn diagram. Then let's go to the next set of questions. So I'll frame it to be like this one. Let's paste it here. This should be C. And for question C, we are saying, what is the probability that we pick someone who plays netball only? Anyone, guys?
It is 12.
So the chances that we pick someone who plays netball only will be there's 12 people out of the 34 that play netball only. Let's go to D. And for D, we are saying, what is the probability that someone picked, randomly picked, does not play any sport? What is going to be the answer, guys?
4/34.
Yep. So if you remember, guys, I said on the corner, that is the number of the people who do not play. So the people who are not participating, essentially. So it will be the probability of, if you think carefully, it will be not soccer and also not netball. So the chances that we have someone who's not playing soccer and netball, they are not participating, that would be 4 people of the 34. Right. So now for E, what we want to ask ourselves is, what is the probability of getting someone who plays soccer and netball? How do we think around this one, guys?
It is 8/34.
On point. So at the intersection, guys, that is where we have the end. So at the intersection, that is where we have the netball, people who play netball, and soccer. So if we go to probabilities, the probability that someone plays netball and soccer, we have 8 of them out of the 34 learners. Right. Let's have a look at the next question, guys. And we'll just change one word, which changes the question as a whole. And the word we are going to change is and. And we are changing it to or. So what is the probability of getting someone who plays soccer or netball? This, guys, I'll remind you, it goes back to what I introduced to you earlier when we were talking about the addition rule. It's very important that you go and look at the previous lesson. When we were dealing with the addition rule, we said the probability of A and, we said the probability of A or B. Let me write it in words first so that you understand. The probability of A or B is the same as probability of A plus probability of B minus probability of A and B. This is a formula that I gave you on the first lesson. And this is the formula that we are going to use because it is able to give us the probability of A or B. So it means what we are looking for here is the probability of soccer or netball. And this is going to be the probability of soccer plus the probability of netball minus the probability of soccer and netball. Right, this is what we are going to do. And there's something which you guys need to take very careful attention of, which is the probability of soccer and netball. For these probabilities, we don't use the probability of only, we will use the probability of netball as a whole and the probability of soccer as a whole. That is what we are going to do. So what is this probability going to be, guys? Anyone?
I think it's gonna be 1.
What do you mean it's going to be 1?
The probability of A or B has to equal 1.
The probability of A or B has to be equal to 1. So when you calculate, you get 1 as the answer. Is that what you are saying?
Yes.
How did you calculate to get 1? So equal to, so we have the probability of a person playing soccer, which is 18 over 34. The probability of a person playing netball, what is it, guys? It's going to be 20, isn't it? Do you guys agree that there's 20 people who are playing netball combined? Right. And then minus the probability of a person playing soccer and netball. There's only 8 of them which are playing both netball and soccer. So what is our answer, guys? Probability of soccer or netball. What is it?
It is
So
15 over 17.
it is
15 over 17.
15 over 17. That is what we have. The key word, which was, it was or. So you just change one word, the problem looks a bit different. Do you guys understand what I did here? Because if you do, when we even do problems that have 3 circles, you will not struggle if you understand what we did here. Does it make sense to all of you? If it doesn't make sense to you, please raise your hand and let us help you. What is it which you are not understanding from what we are doing here? Anyone who's not understanding, talk to us. What do you not understand so that we help you? Okay, so you guys understand? We are going to go to another problem. And let's see, let's pop the problem on our screen. And this is going to be a bit lengthy of a problem, but yeah, we'll get through it. So let me just quickly pop this problem on my screen. Okay, so let's quickly paste this here and just quickly crop it out. Let's start by focusing here. We'll deal with the problems later. So we need to go and draw this Venn diagram, guys. So can I get someone to read this problem for us? One of you can go ahead and read it for us.
There are 200 boys in grade 12 at Marist Brothers High School. Their participation in sports can be broken down as follows: 107 play rugby, 90 play soccer, 63 play cricket, 35 play rugby and soccer, 23 play rugby and cricket, 15 play rugby, soccer and cricket, 190 boys play rugby, soccer or cricket.
On point. So if you guys have a look at what is going on here, what we essentially have is 3 sports. And those are rugby, soccer, and cricket. Those are the 3 sports that we have. And because we have 3 sports, that means we need 3 seconds for our Venn diagram. But as you see, is that we do have people who are playing rugby, soccer, and cricket. And these circles of ours, they will overlap. They will overlap. And here's my advice or my tip when you are dealing with Venn diagram, is that what you should do is start where all circles intersect. So where all circles intersect. So intersect. That is my tip for you. What do I mean? Let's go and draw our box and then start dealing with this problem. So we need a line, another line, another one, and another one. Right. And then we're going to need 3 circles. So I'm going to draw one here. And we'll just copy the circle and paste it here so it overlaps with that one. Let me select both of them. And we need a 3rd circle that will overlap with these 2. Right. So I just need to move that down. Move that. Okay. So there's our circles, guys, and we're good to go now. So let's label these. So let's say we have our soccer as here for my name also, and we have cricket, and then we have rugby. So I said the easiest point to start is where all of these overlap, is the green area. This is where the 3 circles meet. So meaning these are the people who play everything. And if you look carefully on our problem, they tell us that we have 15 players who are playing rugby, soccer, and cricket. So it means there I need to come and put in 15. You guys understand? That is the easiest starting point. Then where do we go next? We go to, after this, so let me say this is tip 1. Start where all circles intersect. And then tip number 2, go to where there's 2 circles that intersect. So do 2 intersections after we've done all the 3. So now we're looking for where there's 2 of them that are meeting at least. So there's 23 people who are playing rugby and cricket. So let's have a look, guys. It means for this yellow here, there are 23 people in total who are supposed to play rugby and cricket. Already we have the 15 that plays everything. So for us to make up the 23, how many people should we put here, guys?
Eight.
It should be 8 people. You guys are geniuses. So there's 8 people in total who play rugby and cricket. Right, very important. So now that we have that, remember I said tip number 2, we do 2 intersections. So now we'll go and say, okay, let's go for the next one. So let's go to soccer and rugby, which would be our blue. Soccer and rugby. So for soccer and rugby, we say there's 35 people who play soccer and rugby. But the 15 is already in there because it plays everything. So how many people are left for me to put here so that we have the blue of soccer and rugby? If in total there are 35.
The people.
Can you repeat?
20.
20. On point. 20 people. Right. So once we are here, guys, we are now good to go. So there's, if you look carefully, another intersection that is left, which is soccer and cricket. So let's go and see if they said anything about soccer and cricket. Soccer and cricket. Soccer and cricket, they didn't tell us. So because they didn't tell us, guys, we are going to leave that as X. Because we don't know. And then let me see. What else are we told? 190 boys play that. So let's figure something out. We need to figure out how many guys do not play anything. Remember, we said we always have a box here of people who are not participating. And if you read it out, if you read our problem, they say 190 boys play rugby, soccer, or cricket. So if the class is 200 boys, then how many boys are not playing sport?
10.
On point. There's 200 minus 190, which is, let's put, which is going to be 10, as you correctly point out. So there's 10 boys who are not interested in doing all of these things. Okay. So now, guys, we need to do some simultaneous equations. to be able to solve for all the other missing things here. So we don't know the number of boys who are going to play soccer and cricket. That was not given. So how do we move from here? Let's think about it carefully. So the total number of boys who play soccer, let me go to soccer. So for soccer, if you look carefully, they told us that we have 90 boys in total. So, and then now we don't know what is here. But if you think carefully, for us to get what is here on the comma, we know that there's 90 boys in total for soccer. So it means I just need to say people who are going to play soccer only. If you think about it, it will be 90 boys minus the 20 minus the 15 that is there, and then minus the X that is there. Those are the number of boys that will play soccer only. So it means the boys who will play soccer only will end up being, what is this, guys? 90 minus 20, that is 70 minus 15, what is that?
65 minus X.
65 minus X. So it means the boys who play soccer only are 65.
It's 55 minus X.
55.
Yes.
Thanks for that. So the boys who play soccer only will be 5 minus X, whatever the X is. And then when we think about now cricket only, we are told that the guys who play cricket, in total, there are 63. So I'm going to do 63 minus the X minus 15, because 15 is part of the cricket, and then minus 8. What is the number of people who are going to play cricket only, guys?
C minus X.
It is
40 minus X.
40 minus X. Okay. So the people who will play cricket only will be 40 minus X. Then let's go to rugby only. So we are told the people who play rugby, they are 107. So we have 107 minus, you look carefully, we have an 8 minus 15 minus 20. Can you guys give me the number of people who play rugby only?
$64.
64. So there's 64 people who play rugby only. Now what we need to do is to solve for the X. Once we get the X, we are done with our problem. Any problem that will come afterwards, we'll ace it. So we need to solve for X. So the way we solve for X is we sum everything and equate it to the number that we are given. So we sum everything, and this everything should be equal to 200 because there's 200 boys in the school. Okay, so let's go to the next page. Do you still understand, guys? Give me a thumbs up. And if you don't, give me a thumbs down and then unmute. And I'll be happy to answer your question. So let's move that. Okay. So what we need to do is to solve for X. This will apply for all Venn diagram problems. Guys, we sum everything we see. So we have 55 minus X plus 20 plus 15 plus 8, sorry, plus 8, and then plus 64, then plus 40 minus x. All of this should sum. I'm missing something. What am I missing, guys? But this will sum to 200. Let's see if you are looking carefully. What am I missing?
The 10.
On point, I'm missing the 10. So equals 10, this should all be 200. Let's make some space and squeeze it in there. Right, that is what we have, guys. So I need you guys to assist me to sum these. So that is plus 15. Yeah. So I need you to go and sum this. 55, 20, 15, 8, 64, and 40 and 10, and give me what those are. Let me pop up my calculator also. Clear with 55 plus 20 plus 15 plus 64 plus 40 plus 10. We see. Are you guys getting the same answer? Missing an 8 here. Are you getting the same answer? Something is not adding up. This one, 55, 20, 15, 64, the 8, 40, the 10. Okay, this is what I'm getting, guys. Are you getting the same thing? 12 to 12. And then you observe carefully. Let me just remove that. Right, that is what I'm getting. But if you look carefully, this x and that x will cancel, guys. And then we'll only be left with minus x there. So we'll have minus x like that equals 200. So what do we need to remove from 212 for us to get 200? Very easy, isn't it? 212 minus 200, this equals x. We just move the x to the other side, take the 200 this side. So our x becomes 12. So it means now, guys, we can rewrite our Venn diagram. Do you all understand? You don't understand, guys, please ask me. Because after you are done sorting your Venn diagram, no question is going to be hard for us. Because we've done the hard work. So let's go and plug in the values on the Venn diagram. So we can see that we have 55 minus x. So these are 10 boys. So what is 55 minus x, guys? 55 minus 12, what is it? Is it 43? Is that correct?
Yes, it's 43.
Point. So we have 43 here. And the x is 12. And the 40 minus x, what is that? 40 minus 12, guys?
28.
28. And look what we have. We have our complete now Venn diagram. You should be smiling, guys. Like this. So Venn diagrams are very easy and they are there in your exam. Your Venn diagram is waiting for you. So please make sure that you do, guys. Revise this. So let's go to questions now. But let's move this to the right, to the other side. And then we'll be able to ace all those questions because our Venn diagram is set. Let's add more pages. So tomorrow you should go and teach others how to do the Venn diagram. And remember, what is very important is the total. We just always need to keep it nearby. The total is 200 people in the school. So let's get our questions shortly. I'm sending them to my tab here. Let's copy those, put them here, and start grinding. So let's crop this and that. And this will be our first question. So remember, with the Venn diagram, you would have done a lot of work prior. So you do a lot of work so that when you get to the questions, you just pull out your answers. So let's have a look at the first question, guys. And the first question is, how many boys do not play any sport? Anyone wants to answer this one? Can you repeat?
10/200.
They didn't say what is the probability that a boy is not playing sport. They said how many boys.
10.
So the teacher would be so happy because you got that wrong. So it is 10 boys. 10 boys do not play any sport. So do you see that, guys, when you were reading the question, already starting to populate your Venn diagram, you were preparing for answers. You were preparing the answers they are going to ask you. Then they say draw the Venn diagram to illustrate the given information and use it to answer the questions below. We've done the drawing of the Venn diagram. So let's go to 2.1. They say how many boys play soccer and cricket, but not rugby? Soccer and cricket, but not rugby. How many are they, guys? Look at how the circles overlap. You want someone who's between soccer and cricket, but not on the rugby side, which is below. How many boys are those?
I think it's 12.
12.
1 point. So we have 12 boys who play soccer and cricket. Okay, only, not rugby. 2.1. Then we go to 2.2, guys. They say, what is the probability that a random chosen grade 12 boy at that high school will take at least 2 sports, rugby, soccer, or cricket? So what are your thoughts on this question, guys? So how do we deal with this?
So I think you have to add the 12 and the 20 as well as the 8, and then whatever number you get lapo, you have to divide it by the 200 that they gave us.
Okay. That is on point. So if you remember, guys, so here they gave us that at least, let's find the probability that these people will be doing at least one or at least two of these sports. But what you should remember is that the probability of A or B or C is the same as the probability of A plus the probability of B. And then what, guys? Anyone wants to take a guess?
Minus the probability of A and B.
Plus the probability of C.
Yep, plus probability of C. That is correct. So with that said, all what we need to do now, guys, is to just add these. So if you look carefully, we have probability. They say at least 2 spots. So what we are going to have is the probability of that they are looking for of either a boy playing rugby, soccer, or cricket. But they say at least 2 spots. We are going to look at the intersection. So our answer is going to be 20 over 200 because there's 2 spots being played. And then there's going to be 8 over 200 because those are 2 spots. And there's going to be 12 over 200. Do you guys understand why we are not doing the 15? Why we are not adding it? Anyone wants to help others there? Why are we not adding the 15, which is at the center here?
The 15 indicates the amount of people that are playing all 3 sports, but the question only said they want at least 2 sports.
Yep, on point. So this, I think it will end up being 1 over 5. Yep, so 15 would be all 3 spots, and the question only wants 2 spots. So that is why we did 20, which was, if you look at 20, you will see that this is rugby and soccer. And then the 8, you will see that it is rugby and cricket. And the 12, you will see that it is soccer and cricket. So if we added the 15, it would all be 3 spots. And they said only 2 spots. So that is the answer, guys, which we would need to provide in order.
So
Yes.
they said we must correct our answer to 3 decimal places, but then since it's a fraction, and when you put it in decimal form, you only get I think you get 0.2. So how would you correct it to 3 decimals?
So if you put your calculator in 3 decimal places, it will be 0.200.
Thank you.
Awesome. Any question, guys? Do you understand this idea of Venn diagram? Just take away the principle. So if we happen to make a mistake here, please go and correct it. But understand the thinking that you should have behind this problem. Think around, okay, what am I given? Let me put these numbers inside here. What is what and what is what? And yeah, you carry on and you do all of this. And you should be okay. So if there's no question, guys, I think we can pause here. Yeah, we can pause here. So I urge you guys to go and try some Venn diagram questions because you should. Make sure that you are able to calculate all of the things that we are calculating here. So if, for example, they were to ask me to calculate the probability of, let's maybe give it a shot. So in 2.3, then they say calculate the probability that we'll have a learner who's playing soccer only. What would it be, guys?
43 over 200.
43 over 200. On point. So there's no question here that should give you a headache. There isn't. Not at all. Let me ask you one last question before we close, which might be useful to make sure that we are able to answer. So what we want to do is we want to calculate as 2.4 the probability that a boy will play soccer or rugby. So how would we deal with this, guys? While you think about it, what you need to remember is an important formula, which I'm sure many of you already remember now. Let me create some space for my formula here. Things should not be squeezed. So you need to remember an important formula, which you can take a guess of what I'm going to write, and you are correct. So if you remember, we had a formula which was when we were doing our addition rule. Probability of A or B is the same as the probability of A plus the probability of B minus the probability of A and B. So which means if they are asking us, calculate the probability that a boy will play soccer or rugby. Remember the U, guys, I told you it is or. So it means I need to use this formula here. So the probability of soccer or rugby will be the same as the probability of soccer plus the probability of rugby minus the probability of soccer and rugby. So I need us to quickly work out these components separately. Guys, what is the probability that a person will play soccer?
43 over 200.
Is it? Let me bring this here. So is it 43 over 200 or is it 90 over 200?
Sir, I think it's 43 over 200 because with the 90 that play soccer, it's possible that they can play soccer and something else, but the question only said they want people who play soccer only.
So our PS will be the number of people who play soccer only are 43. But my question to you is, you saying the 90 includes the people who play also cricket. Is that your argument?
Yes, sir, I'm saying that the 90 also includes people who play soccer and another sport.
Yep. So what we should do in this case, because we are very specific here, we should take our soccer as 43 over 200. And what is PR, guys?
64 over 200.
And very importantly, what is P, S, and R? Did I say soccer and rugby? Yeah. What is that, guys?
$35.
It is what? The probability of a person playing soccer in rugby, what is it, guys? I didn't hear
35
that.
over 200.
35 over 200. So why did you also include the ones who are also playing cricket? Should you include them? Do you understand my question? Are you still there? Anyone
Yes,
wants to
sir.
jump in, guys? You can help them. Should we make it 35?
No.
Okay. So there's two ways we can do this thing. So let's not make it 35. Let's make it purely 20. And I want to show you something. So the probability of S or R will end up being, I need you guys to help me, 43 over 200 plus 64 over 200 minus 20 over 200. What is the answer? The answer should be 23 plus that 60, 80, should be 87 over 200, is it? Is that the case? Looks about right. Yeah.
Yes, sir.
Yep. So this is the answer which we get, guys. And there's something I want you to go as your homework to go and figure out, because it will help you in your learning and you will never forget. So what if when we were solving the same question, we chose to use the combined, where is that picture? I think I moved that picture. Let me see if I can get it back. So I need you to go and figure out, what if I argued and say, and your responsibility is to come and tell me that I am wrong or right. But if I argued and said, let me use for this problem probability of soccer or rugby, I'm going to say, what if I went to say soccer, I have 90 folks. So I'm going to do 90 over 100 plus rugby, I have 107 over 200, like that. And then I come and look at the intersection of the two, but let me think carefully. Soccer is 90 minus 12. And then minus, we are looking at soccer in rugby, which would be 35 over 200. Why is this off?
It also includes the people who play cricket.
Okay. So if it includes the people who play cricket, let's go to soccer and remove 12. So you're saying there's people who play cricket, and if you look carefully, there's 12 who play cricket and soccer. So we'll leave the 15 that does rugby still. And if you look carefully, you will then say 90 minus 12, which is going to be 78 for soccer. And then for rugby, it was 107, but there's people who play cricket. So 107 minus 8, that gives you 99. 99. Do you now feel like this is a bit correct?
No, it's still incorrect.
Why?
Well, because for soccer, the 20 and the 15 is also including people who play soccer and rugby. But the question only wants you to give them the people who play soccer only, plus the people who play rugby only, and then you're going to subtract people who play soccer and rugby.
Mm-hmm. So it means on the soccer, we need to take down another 15, is it?
15 and 20.
15, and we're doing rugby and soccer. Why are you taking another 20 down?
Also, I thought you were doing soccer only.
Yep. So you are correct. But let me leave this as a question for anyone who's not getting why I'm asking these questions. But yep, let's leave it here, guys. You must go and argue with someone you know tomorrow in class and say, but why are we not using 35 over that? And why are we not doing this and this and this? Argue until you understand why we did what, and yep, come tomorrow and tell me what you find. Okay, guys, I think let's end here for today. I hope you understood. If you did, please give me a thumbs up. If you don't, prepare and come back tomorrow and make sure that you do ask questions. What we did here is very important, and these marks are waiting for you. The steps are pretty much the same. You just need to make sure you understand your Venn diagram, do your analysis properly, and you should be okay, guys. Please make sure you do rewatch this lesson, especially if you might have forgotten some of your principles of Venn diagrams. I see a hand from Tobela. You can go ahead and ask.
Sir, what if they say what is the probability of a boy who has randomly selected at least one sport?
What do you think we should then do? Did we not do that? Okay, no. So what do you think we should do? A boy who's doing at least one sport. Anyone wants to help them there. So we'll only focus on the individual sport. Anyone wants to give that a shot?
We have to add 43 plus 64 plus 28.
Yep. You understand, Tobela? So we look at, for soccer, the probability that a person will be playing soccer only will be 43, then 28, 64 of that. So we'll say 43 over 200 plus 28 over 200, and then plus 64 over 200. And that would be the probability that a boy randomly selected will be playing at least one sport. Do you understand? Awesome. Thanks for that question, guys. Make sure that you do revise these lessons, okay? For today, I think let's end it here, guys. Cheers, and we'll share the notes with you. Make sure that you do check out the lesson. Take care, and bye-bye.